Depending upon the implementation, the streaming SVE vector length may be same compared to the non-streaming mode, or it could be different. Once we enable streaming SVE mode, all the SME instructions are legal to be executed. As I indicated earlier, streaming SVE mode is the only mode wherein SME instructions are legal and can be executed. And a subset of SVE2 instructions are also available that can be executed in the streaming SVE mode. All of the instructions of SVE cannot be executed. The chapter in ARM SVE instruction descriptions details which instruction can be executed, which instructions cannot be executed. Non-streaming SVE mode is the regular execution mode of the PE when the PE has disabled the streaming SVE mode. So if the implementation supports SVE and you have not turned on the streaming SVE mode, then the effective vector length will be that of the SVE, what is referred to as VL, and regular predicate registers are available. Vector registers Z0 to Z31 are available. SME instruction execution is illegal in non-streaming SVE mode. All of the SVE and SVE2 instructions are legal to be executed in non-streaming SVE mode. Okay. Basically, we are trying to give a difference between what is a streaming SVE mode and what is available in streaming SVE mode. Streaming SVE mode enables execution of SME instructions. SME instructions provides high performance benefit for matrix data computation and vector data computation, and the different predicate mechanisms available in SME architecture enables building simple control flows for executing matrix-based computation, matrix data processing and vector data processing. In addition to entering streaming SVE mode, we will have access to ZA storage in streaming SVE mode. We have to independently enable it. Once enabled, the vector registers width of Z0 to Z31 would be same as the ZA storage width. So the complete ZA vector array width and the Z vector registers width will be same, and the support for SVE2 instructions enables effectively using these registers to load from memory, store the contents back to memory, manipulate the data in the ZA array, move it to different vector registers, perform the outer product of the matrix computation, and directly be able to store it in the ZA storage. So those are the key features that enables high performance throughput for matrix computation in streaming SVE mode, okay, which was not available in the non-streaming SVE mode. The whole intent of SME, Scalar Matrix Extension, is to enable high throughput for matrix computation that we are able to successfully do because of ZA storage and enabling certain SVE2 instructions that can actually directly compute the outer products and store it directly in the ZA storage. How do we enable the streaming SVE mode? There is a dedicated field bits added to the P state. They're referred to as SM. Just let me open the marker. The SM field bit added to the P state can be used to enable the streaming SVE mode or disable the streaming SVE mode. When the streaming SVE mode is enabled, the registers Z0 to Z31 are available. Predicate registers P0 to P15 are available. Whenever we make any changes to the SM field, these registers are automatically reset to 0. Once we enter the streaming SVE mode, we can choose to enable the ZA storage by programming the ZA field in the P state register. We cannot directly access the P state ZA field and SM field. We use dedicated instructions. We can use MSR instructions. These fields can be programmed by programming the SM field and ZA field in the streaming vector control register. The SVCR is the streaming vector control register. We can program these fields using MSR instruction. Also, there is an equivalent instruction available like SM start SM, which will enable the streaming SVE mode. To disable, you can use the SM stop SM instruction, which will disable the streaming SVE mode. Similarly, we have SM start and SM stop for ZA field as well to enable the ZA storage and disable the ZA storage respectively. Also, to enable both simultaneously, that is streaming SVE mode as well as ZA storage, we can use the SM start instruction. To disable, we can use the SM stop instruction. Let's have a quick look at how we can switch from streaming to non-streaming mode and non-streaming mode to streaming SVE mode. Processor usually will be, when you start the execution, you might be in the non-streaming mode. Assuming you are in non-streaming mode and a set of SVE2 instructions are getting executed, suddenly there is a need for a particular application to execute complex matrix computation or complex vector data that might need certain SME instructions to be executed. You can execute the SM start instruction that will enable the streaming SVE mode by setting the SM field and ZA field in the P state. The SM start instruction can enable both streaming SVE mode and ZA storage simultaneously. If you want to independently start, you could use the alternative instruction SM start SM, SM start ZA. Okay, the SM start instruction will simultaneously enable both SVE mode, streaming SVE mode and ZA storage. Once the streaming SVE mode is enabled, all the SME instructions can be executed. Also, it enables a subset of SVE2 instructions. These instructions can be executed to handle the complex matrix computations. Post that, you may want to switch back to the non-streaming mode. You can execute the SM stop instruction that would disable the streaming SVE mode and ZA storage. So this way, applications can switch between streaming and non-streaming mode. Whenever there is a high workload, you can switch to streaming SVE mode. When the workload is regular and you do not have any hectic matrix and vector computation, you can switch back to non-streaming mode. The SME instructions are targeted for matrix computations and vector data computations. As we discussed earlier, the complete ZA storage data can be used as input for the SVE2 instructions, for SME instructions. Also, the result can be stored back directly into the ZA storage. Thereby, every time reading the memory, bringing the data into the registers, performing the data processing, and then storing back the result back into the memory, that particular task will demand high bandwidth. That can be avoided because we have a huge ZA storage, which is a two-dimensional array of data that is available. And since we'll be storing the data there in the ZA storage, there is no need to every time read from the memory and store back to the memory. Thereby, the cost of reading from the memory and writing back to the memory for every computation, for every data processing instruction is avoided. Okay, which helps a lot for AI-related, machine learning-related, and high-performance computing applications. Hence, the performance benefit goes up with SME.